all read my talk title for the last 5 minutes, so I'm going to skip to the next slide. First of all, yeah, I really love Scale. I really love being here. I have the sneaking suspicion that they put me in the last slot on Sunday because they knew I was going to stay for the whole thing anyway. But I'm so excited to see everybody here. Another thing I really love is the ocean. I live in Seattle, and we're not directly on the ocean, but we get so much waterfront with Puget Sound and all that. And so over the last year, I've spent a bunch of time on the beaches learning how to be a beachfront naturalist for Seattle Aquarium, and it's like really cool, all the things you learn about seaweed and, you know, our local whales and shells, seashells, other things. In general, I think computers exist to serve humans, not the other way around, even though in our daily lives it may feel the opposite sometimes. I feel like some days, at least 15% of the reason that I chose to become a software engineer is so that I can show the computers who's boss. I also play piano. The piano is definitely the boss of me. And you already know I write software at Pulumi. We do infrastructure as code, which may or may not be relevant to the story of this talk. Oh yeah, you can find me on GitHub at my name. I'm the only Guinevere Saenger in the whole world. You can find me. So why this talk? Last year, I was tasked to overhaul one of our tools at Pulumi that involved some way of automatically provisioning Docker containers, Docker images, and general Docker functionality automatically using our Pulumi tool. And it turned out we could already do this, but the way that it was done was we wrote code to shell out to the Docker CLI and go Docker run dash blah, blah, blah. And sometimes that didn't work so well because sometimes that shell that we were shelling out to didn't have the correct authorization. Or we ran into race conditions. And so when we were deciding to bring forward this tool into the new world of you know, version 4, I proposed that maybe we should use a client library instead of a CLI. And so that's kind of how this talk started, because let's have a show of hands. Who here uses Docker at work? Who here has never heard of Docker? Okay, good to know. Who here has had to write convoluted bash scripts to get Docker to do the thing that they want to do? I'm so glad you're here. Because I was like, what if no one does? And so a couple days ago, I was talking about my talk with a few people, and they said, well, if I just use Docker Compose so that I can just put all my command flags into a file and then have that run in. And I'm like, is that what Docker Compose does? Gosh. Anyway, this person's here in the audience, and they are way better at explaining Docker Compose than the Docker docs, which will be a topic a little bit throughout this talk as well. So what is Docker anyway? You know, it's an open source container platform. It's a very popular container runtime. It runs almost anywhere, and it runs almost anything. One important part of the Docker ecosystem are the container registries, where you can share your wrapped up containerized app with all your friends. And they have a very cute whale logo, which does appeal to me as a beachfront naturalist in training. So, why do we shell out? Ooh, 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 I got some laughters, yes. Go watch Demolition Man, it's a great movie. Well, you know, so this is how most people build Docker images, at least when they get started, right? Somewhere, some process or some person runs Docker build, tag, image name, everything in this particular folder, right? So this looks like a fairly simple command, right? But it's still a command, and you still have to like use a CLI to do it. It's not too bad, right? Like, it's pretty simple, it's straightforward, you know what's going on for the most part. And again, it assumes at least a human operator by proxy. Somebody knows that somewhere this particular command is being run. So we shell out. In Go, which is the language I'm going to use in this talk, that looks like this. And Again, that's fine. It's a little bit convoluted, but the Go exec package has actually a few better options to handling. I always find it's a little bit more obvious, but I'm really bad at bash. And I hear that there are mythical people out there who are in fact good at writing bash scripts. And there might even be a few people out there in the world that are good at debugging bash scripts. And I'm certainly not one of them. So if my bash script that runs a Docker command fails, I'm just like, I don't know what to do. I give up. But you know, as we all know, not all Docker commands are short. I'm not rewriting this in Go for you because that is also kind of convoluted. So, but again, sometimes shelling out is the right choice if you have a very simple image, if you really just need to like run your development container locally and then get into it or attach something very easily, that's great. Shell out, please continue. But sometimes the shell just doesn't make sense. You know, from the perspective of this whale, he doesn't even know. He can't even see the shells, right? They're too small. Right? So sometimes we want to run Docker processes or build images, right? In a lot of my jobs, when we use Docker, it is to build an image and tag it at deploy time, right? Or at publish time. When we go live with a version, we want to cut a Docker image and push it to a registry. And we also don't want to do this manually because who here loves release automation? Exactly. We want that stuff to be automated, right? So that's why all these other tools exist. I did put Pulumi on there. Again, I'm not here to sell you on Pulumi. I'm really just here to share some code that can make you bring up Docker images by yourself. So again, why do we use the whale in the first place? It allows us to be flexible. It allows us to have, you know, any environment we want on almost any operating system that we want, and we can control it, and that's actually really great. But, you know, getting into the whys of Docker would be a completely different talk, and as I hinted earlier, I'm not that much of a Docker specialist. I build tools for developers. That's what I love doing. I love making developers happy, and if that means I have to wrestle with Docker on occasion, then I will do that. But I bet there's people in the audience that know more about Docker than I do. And I also bet that, you know, there's areas of Docker that I just haven't even ever touched. So if you want to learn why Docker, their website covers that part. But in short, we should be able to create and use Docker images without the need for an interactive terminal. So I'm going to switch to code. I'm going to switch to my editor here. But if you want to follow along, you can feel free to, I just pushed the code to GitHub this morning, and my apologies, it's incredibly rough. But if you want to follow along, I'll probably push the fixed versions after I go through everything later this week. But yeah, so it's available. Whoops, that's the next slide. So we are going to switch to my Docker Talk repo. All right, so let me make this a little bit bigger, I think. Yes? Does this not, wait, okay. There we go. That'll work for the code. Great, so I have here, in my file structure, I have a very simple sample app. It runs a script that says, hello, scale. I'm going to make this bigger too. There we go. And it has a Docker file that pulls up Go. Wow, this editor's terrible at that. It pulls up Go, and it runs my hello Go file. And when I run this container, it will say hi to everyone in the room, because that's what we do at demos, right? We write hello world, except the world is scale today. Anyway, here is the actual code that I would like to show you. In my main function, the first thing I do is I'm going to go and get myself a Docker client. And so my client library is literally right from here, from the Docker, from GitHub. from Docker itself, and it has a client. And in fact, this is what happens under the hood when you go docker build-t, right? They use this client. They're just like way better than the rest of us at running it because they can ask the people who wrote all the low-level libraries that nobody else understands. I know you laugh, but this is actually like how it is, and it's been a struggle at times. So again, I needed a way to create a Docker image that didn't shell out to an extra shell, and so this is how we do it. We get a new client, we get some options from our environment. You can actually set a lot of these things. And here's the thing, what you will see here, and then we basically copy a bunch of the things that Docker does. So we create a tar file from our app right here, over here. That's our app. I'm not going to move that, sorry. And then we have some options here. So these are some of the things that we can tweak. These roughly translate to our command line flags. Not quite the same. I'm going to tag my image. Saenger is my Docker Hub name, so I'm just hard coding this for the demo today. My Docker Hub is public. You can look at all of the demo images that I pushed up there throughout my career, and if you have any use for them, good on you. So hello, go. Sunday at scale. Whoops. Don't worry, I'm not going to do a whole lot of typing here. We have a version. This version refers to the Docker builder, and I'm going to use the old builder. This is the original. This is the original builder that you don't even get to use anymore when you use Docker. And I'm going to build for this platform, all right, and then I'm just going to run image build on my client. Everything else in this file is a couple helper functions so that you can all see the output from what happens when I run this program. So let me minimize this guy. Let me make this a little bigger so you can see clear. Whoops. Okay, so I'm here in my demo folder, Docker talk, and Docker v1. Awesome. Wait, hang on, what changed? Oh, that's fine. Right, I changed main.go. And I'm just going to run main.go. And if I did everything right, you should all see some build output now. Now, this is building really, really quickly because I already ran this in my hotel room to make sure that you could all see some output. But this is the output that you see when we're pulling the Golang Docker image, and you see some of this stream output. If we wanted to clean this up, we could parse the output and make it look nicer. I did this, in fact, one of our tools has an interactive print output terminal, and so some of this actually just already looks prettier over there. But this is meant to give you a basic starting point. Cool. So I just built a container image, and I should have shown you this before, but Docker images, here we are. And just 43 seconds ago, I built an image called Hello Go Sunday at Scale. Cool. Let's see what happens if I run it. I can run this using the Docker CLI, but because it only prints out, hi everybody, the container exits immediately and you wouldn't see the pretty output. So I will run this one manually for you. Haha, but it won't run. I built it for the wrong platform. I actually meant to do that. So we can go back here to my program and change the platform. And I'm on ARM64. And notice how this is actually going to be important later because we are only building for this one. Actually, yeah, we're only building for this platform. So I'm going to try and run my program again, right? Because I want to build an image that I can then run as a container on my native infrastructure. Sweet. So let's do that. This is going to fail too. Oh, it succeeded. Okay, great. Why did this succeed? Oh yeah, it did succeed because I'm still using the old builder. Right. But now, I'm going to run this. And here we go. Hello, everybody. So that's awesome. Now, a lot of people, when they want to modernize their Docker infrastructure, they ask about build kit a lot. And again, there's a lot of confusion. People sometimes think that Docker build X is the same thing as build kit, but it kind of is and it kind of isn't. What build X is really just a CLI representation of all the features that build kit can offer. And all that build kit really is a builder. So when I ran my Docker images before, you see that there is, you'll see that there's a Moby build kit container repository right here. This basically is a way to allow, it's kind of their way to allow me to run build kit on my machine and build Docker images that have more modern capabilities. Among some of them are the ability to build cross-platform images, to build for multiple platforms at the same time. So I'm going to change my builder type, and I'm going to use build kit here. Because you can still do this with the classic Docker client. And when I say classic Docker client, that is a client that you use to run containers. That is a client that you use to push images. But for a build client, for the client library for Docker build, you actually have two choices. You have a buildx library, and you have what I'm showing you right now, which is the classic Docker library. I'm going to use this. I'm going to try and build for ARM64. This one will fail. Pretty sure. It didn't. Okay, well, this is working great. I meant for this to fail. Okay. So let's see. Where's my images? I just built another one, so that's cool. Things. Great. So, right. No, I know now what's going on. So I have an image. I can build it a number of ways. Awesome, right? So there's a couple other options that you can tweak on these image build options. Some of them work well, and other ones are a little bit in development, or if you ask about it in the Docker community, they will gently tell you, maybe you want to use buildx instead. And I will show you that in a minute. But before I do so, I want to go ahead and actually push this image to my registry, right? So if I have on my auth set up, I'm using super lazy auth. First, I'm going to log into the registry using local auth config. Do not do this in production. Go ahead. There we go. Let me go back here. So right after I built my image and got all that beautiful build output, I'm going to go ahead and I'm going to need to undo some of my imports here. Base 64. Come on. Import package. Thank you. There we go. This should compile. So what I'm doing is, first I need to log into my registry. I use Docker Hub. That's pretty straightforward. Some people use registries that they literally just created as part of their same development stack. One of the awesome things about using a library like this is that it forces you to think about all these things right up front. None of this is going to make you building your Docker containers any easier. It's just moving the complexity in the front rather than at the end of it. So basically, I like this because now I have the ability to basically choose how I authenticate, and I will know, because I know what environment I'm trying to run this in, what that environment expects, right? So obviously getting a password like this can totally work. It works for GitHub Actions. You just put it in as an action secret, and there you go. You've got your Docker password. You've got your, you can make the username dynamic. Again, for this demo, I just used mine. And again, you can make the server address dynamic. All this stuff is now obvious to you, and you don't have to run any kind of wait, tell me which registry we're logged into while you're shelling out, because your auth config just knows. So that's one. And then the next thing is we're going to push the image. And I'm just going to go ahead and do very terrible things. Ideally, this would be a variable that I declared on top, but it turns out for me, I always like to be reminded when I'm running through this as part of a demo. So now we have some image push options. Here, we're just passing it the specific authentication. How are we getting into this registry? Great, so hopefully this works, and if it doesn't, now we're gonna have to debug. Let's go. Great, so at the bottom here, you see some output from pushing. So, requested access to the resources denied. Let's see here. I wonder if my Docker password is busted. Let me switch real quick, because I did, in fact, grab. Oh, I don't have my Docker password in here. Okay, that's what it is. Let me quickly set this. Cool. All right. Docker, what did I call it? I called it Docker. This is great, Docker pass. Pass equals. Here we go. Yes. Okay. Thank you for your patience. This is what I get for using my direct Docker Hub password in a demo in front of people. Awesome. So this should work now. We're seeing, oh, all right, and now you should see some push logs output. So that's pretty awesome. Neat. So now if I go to Docker Hub, whoops. Where's my Docker Hub? Docker Hub, here we go, and I refresh. We should see a new image called Hello Scale. Here we go. All of this without using the CLI. I'm pretty stoked. This is pretty good so far. It's a pretty good start. And I was really pleased when I saw this working on my other tool. Great, so what's next? Sometimes these particular things throw you a curveball. There's a lot of stuff that you can configure. I think I will skip again showing you how to run the container, because again, it's literally just like a client.container run, container start. If you have, it's the documentation on this throughout the Docker repositories is unfortunately sparse. But if you've gotten this far and you have a client, most of the time your IDE will tell you what to do, you know. Cool. So as I mentioned before, this is a client you use to run containers and to push images. But this is not the client you may want to use to build your images, because I will show you in the options right here what happens if I want to build a container image that truly can run anywhere. If I truly want to build a multi-platform container image, you have no idea how many people asked me for a multi-platform container image, and I had to tell them, unfortunately, you're going to have to run a for loop and run this code multiple times and push up multiple individual images, one for each architecture that you want. And they said, what do you mean? I can't just do this? And it turns out you can't. And that's really unfortunate. And I think the Docker people agreed, because they came up with a new way of doing this, and that is where the BuildX client library comes in. So let me show you that one. Similar story, we have an app. We have an app folder. It has a Docker file. I'm just running Go because I'm boring. And this one says hello build.x container. Let me show you. It's a little bigger right here. Cool. So in my Go file, my code here, the big difference here is on line 10, we're using build.x build. And we're using a bunch of other imports. You will see that a lot of these, this whole thing needs a significant amount more setup. So it's a little bit more complicated, but thankfully you all work with Docker, right? You know the pitfalls, you know what things are called and what you want and what you're looking for. So hopefully this isn't going to be too overwhelming. So first we're going to get a new Docker client. Then we're setting up a build context. Then we need to get our build options, which this one is, I don't know why this is called PB. It is one of the libraries up here. Where is it? Oh well, let's move on. So we have some build options, and again, this is really just where we're telling our client, hey, please look for my files, please look for my application, my Docker file in the correct folder. And again, this is just where you can keep your Docker context and your Docker file name anywhere, and you can just configure that, which is kind of nice. So then we also have to provision a builder. And this depends on your operating system. And what this does is basically it's using the default builder that Docker uses on my computer. But it turns out you can bring your own builders if you want. I don't know that much about Docker builders, but probably you do. And this is where you would feed those in. And that's pretty cool too. Please apologize. I want to apologize, by the way, for my error handling, because this is literally just a demo script. This is never how I would handle errors, but this way you can all see them when my code falls on its face. So then our builder needs a little bit of setup. We need to load the build nodes. And finally, we're getting to this line, which is our payload, which is our options, which hopefully is where we get to configure some of this stuff. So another thing that build.x does or doesn't do, it loads our Docker images into its own context, and so a lot of the time when I use this, the image gets built and then it gets put into a secret location on my computer or in some kind of cache, and I don't know where it is because it thinks I'm just building the image and doing something else with it. But maybe I want it in my local image store so that I can run the container and show you all. So that's what this does. So I'm exporting my Docker image to my local image store. Again, it needs a bit more setup. Here we have our payload. I'm not sure that we need these inputs. All right, so then we got a little bit of a helper function for printing. And finally, on line 94, we build. We pass the build context, we pass the builder nodes, and we pass the payload that we defined up here. And the payload really here is, I'm using the default builder as explained here. And this is where we put things like, hey, I want to tag my image. And you already see, I can tag multiple tags, right? So I can tag buildxhello.go. I can tag, I don't know, someone pick a tag name. That's fun. Say what? 3 seashells. Oh, yeah, I like that. 3 seashells. Sweet. Awesome. So when I do this, I'll get 2 images. I'll get 1 image, right? But 2 tags. We hope. Let's find out. And then again, I have some support functions that are basically around handling the printing and the authentication. Yep. Oops. I apologize for everything always being on the bottom here. Let's see what happens. It's thinking. All right. Very cool. Docker images. Our moment of truth. Oh, it's not there. Shoot. Oh, no, there it is. Here we are. It's just the same image. It's got a new tag. I was like, no! Anyway, I built this 2 days ago and didn't change it since. That's right. I didn't actually change the print output for you this time. Yeah, so we got this new tag. Y'all can see this just happened, right? Because I definitely didn't have a container here that was tagged with 3 seashells. So that's awesome. And again, now we have a lot more options. What we can do is we can go ahead and Docker inspect this one to see what infrastructure it's built for. Oops, I copied that, right? Inspect. Here we are. So here we get to see a bunch of interesting stuff, and it's built for the local architecture ARM64, which is interesting because I actually didn't tell it which platform to build for. But it picks the one that you're running on by default, which is reasonable, right? So yeah. Let's go ahead and see what happens if we configure this a little bit more. So we can do platforms. Where's my platform here? ARM64. I want to build AMD 64. And this now will be true cross-platform building. Right? Type, what is happening? What am I doing wrong? What? This is very weird. Okay, I think my IDE is just on the fritz. This will be fine. Did I do something weird? Nope. Nope. Oh, wait a minute. Hang on. Can't use string as a type specs.platform. Oh, God. This is fun. Platforms. I swear, this was a string literally yesterday. I should have pinned my version. Sure. Anyway, maybe in the interest of time, I shouldn't debug this in front of everybody, but let it be known that it is absolutely possible to specify multiple platforms. You might have to jump through a few more hoops to do so. I won't show you again this one for pushing this image. You use exactly the same client as before. You use the basic Docker client. It will push your image to any registry that you desire, provided you're authenticated. So that's pretty cool. I'm going to just show you running this container, Docker run, just in the interest of completeness. And here we are, and we have a buildx container that was made with the buildx library. So 2 libraries, and let me get back to my slides because I think I made you a summary. Again, this code lives on this demo repo. I do not intend to maintain it by any means, but I put it up there so you can check it out later. So we have a classic Docker library for building. Classic is a little easier to use. It does support BuildKit, but not with all the options. It does not support all modern Docker capabilities such as multi-platform builds, but you do use it to run containers, to push images. BuildX is way, way more configurable. It has all of the options that you can do where people just, yeah, but like if I use the command line, it's like I can do all these things. Yep, you can do all that with the BuildX library. It supports custom builders. Bring your own builder if you need. It also supports BuildKit because it literally is made for it. And as far as I know, it focuses only on build capabilities, and that's what it does. So the Docker ecosystem is huge. And when you look at this, what happened last year was that the Docker community decided to put a lot more effort into like more more open source, more public, more usable support for the BuildX capabilities in this way. And I think improvements get shipped every day, and unfortunately, frustratingly, sometimes documentation that was meant for one of these libraries is kind of stuck in the other, and it's very easy to get confused. And so I did not have that great of a time dealing with this last year, hence this talk, because I thought I'd share so maybe the next person doesn't have to suffer. So there's a little bit more here. So why did I go through all this trouble, right? I think I talked about that a lot, but so yes. I work at a company that does infrastructure as code. One of the tools we do can provide Docker containers. It can build Docker images. And I thought it would be cool to show you yet another way to create a Docker image without using the command line. Well, without using the Docker CLI. Slight asterisk. So let me go back to my code. Here I have a folder called Pulumi. And I did write this in Go. Even though I could have used TypeScript, I could have used Python, I could have used, what are the other ones? .NET. I could not have used .NET to create this demo for you because I have never used .NET in my life. But if you are familiar, you can use this. So Pulumi supports a bunch of languages, but I stuck with Go because here we are, and that's what I've been using the entire demo. So basically, what this is I'm importing two libraries. I'm importing the Pulumi Docker SDK, and I'm importing Pulumi. And what Pulumi does is it creates cloud infrastructure for you using the Pulumi command line. You have to install a bunch of things. I just thought it'd be fun to see. But if you kind of look at this code a little bit, I have my demo image here. It's called demo image. I'm going to call it scale image. I'm going to build it for my own platform, ARM64. Again, same story. I have an app with a Docker file. It does something. I'm going to tag it with my name. And my name is scale image. I'm going to call it Sunday. Great. I'm going to skip push. Great. So this is basically the tool that I built using the Docker client libraries that I just showed you. And this is just a quick little demo here. Pulumi. And I'm going to run Pulumi up. I'm going to create a new Pulumi stack. Actually, let me X out of that and clear so you can all see a little bit better. Pulumi up. Create a new stack. I'm going to call it demo stack. Great. So basically, this should be a little bit familiar if you're at all familiar with Terraform. It's basically going to show you a preview of the resources that I'm creating with the tool. And one of those resources is basically just all the information that Pulumi needs to do this. And then I'm making a Docker image, and it's going to be called scale image. I also get a little bit of a warning here because we want to make sure we're building for the right architecture. That's fine. I think I specified that's the architecture I want. Great. And so now I can hit confirm, and I should see some output if I did this right. So if you were watching really closely, you can see the build output that kind of was displayed in that little message window. I can do that. I can change the thing one more time. But now let's see what happens to my Docker images. So here we are. 18 seconds ago, I created a new image called scale image. And yes, I can also push to the registry doing this. I don't know. So I'm going to skip push, undo skip push. So I think this should just automatically authenticate me because I have my Docker password set, but I don't know. I might need to set up some authentication here as well. Let's find out. So again, I'm just going to like rerun this command. I see, okay, Docker IO repository. Okay, I'm gonna do that. You know, I wrote this tool. You'd think I'd know how to use it. It's been months though, in my defense. Yes, I want to perform this update. I might not be authenticated as part of this program, so that might be an issue. Oh, no, there we go. Awesome. Sweet. So that is kind of just a little sneak preview into what Pulumi does. Let me show you if we can see this on my Docker Hub now. Scale image, pushed less than a minute ago. All right, so it works. It's there. Ta-da! I feel like I should do like a little curtsy here. But wait, Guinevere, you say you marketed this whole talk about like no more shelling out. You just used a command line tool to create a Docker image. Yes, but I did not use the Docker CLI. Additionally, it turns out that Pulumi does have ways to automate this kind of thing, and this talk is not about Pulumi, but you do not have to use the Pulumi CLI to use Pulumi. You can run it in a program just as well. We have libraries that help you do that automatically. So you don't have to have a human typing into a terminal, do the thing. You can just kick off the process and have your coffee. All right. Where is my final slide? I think we're at the end of this. Yes, thank you all so much for being here. Last talk on Sunday before the keynote. You can find me at both those things. I don't tweet very much anymore, but I occasionally check my DMs. And I am always on GitHub. Yeah.
We have one question, apparently.
Let's see if I can answer it. Probably not.
First, thank you. It was really cool. Have you looked into alternatives to writing the Docker file itself?
Alternatives to writing the Docker file itself? No, I have not, because that's not what we do. I mean, that was just not part of my job task description, right? You should be able to just feed whatever process creates your Docker file into this as well, right? But yeah, the short answer is I haven't. I just want people to bring their setup and be able to make images. Yeah. But I'm curious about what you were thinking of, perhaps.
Like why?
Yeah.
Like why? Just because most Docker files are, it's like the equivalent of a shell script. So just thinking maybe there's a better way than maintaining those by hand.
Sure. Yeah. There's a question in the back.
Do you know if there's any like libraries for alternatives to Docker for building, let's say, like OCI images with this approach?
I don't. I bet there might be. But given that I was pretty convinced most of last year that surely the BuildX library, that the build kit support would be better in the basic Docker library than it is, or more, I shouldn't say better, right? Like, I'm sure there were many reasons why it didn't quite make it. But I don't know. I don't necessarily compare container runtimes as like, because again, we don't run this ourselves. We just want to make sure that we have this available for people who do run Docker. That's basically, that's not an excuse, it's just a reason I don't know. Be curious to find out, yeah. Does anyone know of?
Yeah, Red Hat has some tools that are an alternative, like Podman and Builda. and they make OCI images.
Right. I did go to a Podman talk, but that was a very long time ago, 2 days ago at scale. That's a long time. Thank you.
Yeah, I think Red Hat had a speaker here, I believe at Scale last year, and that should have gotten recorded, so you can probably find that. Okay. Any other questions? If not, please join me in thanking Gwen for a great presentation.
Thanks for being here.